So let's start talking about some particular kinds of expressions which are called linear expressions. Let's look at an example. Let's say there's a museum where the entry fee per family is 100 rupees, but also there's also a separate entry fee per person which is rupees 20. So just imagine if you have, let's say, a family of three. So if there are three people in the family, the the total cost would really be not just if there are three people in the family. So family of three, if you have a family of three, then the total cost, well, first you have a family, so you have to pay 100 rupees in any case. And then there are three people, each person has to pay a cost of 20 rupees. So the total cost is going to be 100 plus 60, should be 160 rupees, right? So this is how I just want to clarify what I mean by this. So now we can really, if the total number of people in the family is X, so let's think of family of X. So now we have X number of family members. So the total cost is going to be 100 plus 20 into X, or 20X. So that's what would be the cost. And now please note that the power of X here is 1. So I'm going to write it 1. And this is called a linear expression. So this is called linear in X in particular, linear in X. And it's linear because if you look at the power of X, it's just equal to 1. Okay. Now, in general, if we have expressions like maybe an expression like 6x plus 4y plus 3, we will call this expression linear in x and y. So this is linear in x and y. So in both the variables, it's linear. It's linear in two variables. Now, if you have an expression like x squared plus 3, this is not linear because actually x has a power of 2, and this would not be considered a linear expression. In a linear expression, so now you have to be careful. Um, in any term, so I'll give you an example. Let's look at another expression, like maybe we have an expression like x plus 2y plus 3xy plus 4. Now you may think it's linear in each one of the variables because each one has a power of 1, right? Because when you don't write the power, it really means 1. But that's not how we think about it. When we have in every term, so look at this term, here's one term, so here's one term here. So if in a term you have this coefficient, so let's get rid of the coefficient and think about just the variables. So when you look at the variables, you ignore whether it's an x or a y. So you have one power of x and one power of y. So what you really think of this is that it's really like 1 plus 1, which is equal to 2. So the way, the way we think about linear expressions is that each term should have one variable in it, and that variable should only have a power of 1. That's how we think of linear expressions. So now let's talk about adding linear expressions. So let's have a simple example. Let's look at a particular case that we have a country A, and from a country A you go to country B, and from country B you go to country C, and you are walking on foot and you're carrying some apples with you, and let's say on each apple there's a tax. So you're going to pay a tax of 2 rupees when you cross from A to B, and you're going to pay a tax of 3 rupees when you cross from B to C. So okay, so there's a so here's going to be a, so you have a rupees 2 tax here per apple, and here you have a tax of rupees 3 per apple as you cross countries. So your total cost, so the total tax for you as you go from total tax as you go from A to C, well, let's say you're carrying X apples, and the number of apples you're carrying X apples. Okay, so each apple got this cost. So you can see in the first case, you'll have to pay a tax of 2x as you cross from A to B. But then as you cross from B to C, you'll also have to pay a tax of 3x. So now if you think about it, per apple, you're really paying a cost of 5 rupees per apple, so you really say it's 5x. So really what you're doing is that you're adding the two coefficients of x, which are 2 and 3, and you say actually that 2 plus 3 is equal to 5, and that's what you've used over here. So that's what's called adding like terms. So you just add all the x's when you need to. And similarly, you can subtract all the x's. So for example, if you, from the total cost, you want to figure out what's the cost of going from A to B. So let's say you have the total cost of 5x, and you say, let me subtract off the cost from B to C. Well, then you're going to be left with 2x. And that really happens because you're really thinking about 5 minus 2 is equal to 3. So you're working out the cost per apple, and x just comes along for the right. Okay. Now you can think very similarly over here, and all the usual rules seem to work out very well. So for example, let's say we have a similar problem that we had, except now we want to also add the cost per person. So let's say the total cost, so there was a person who was carrying the apples as they walked from A to B, and then they walked from B to C. So the person cost, so let me add the person cost. So this guy, so the person, just to walk across, is going to cost some energy and food and everything. He cost rupees 4 as to go from A to B, and then there was a cost of 5 rupees for that person to go from B to C. But there was one person who was carrying all the X apples. So 4 will not get multiplied by X or with this. So then you can see that the total cost, if you include the cost per person, so the total cost, so again, including the person cost, so the total cost paid, I shouldn't be in green, let me erase it. So let's say the total cost, I'm now including the cost of the person. So the total cost as you go from A to C, because there was also the travel cost of the person, you paid 2x. So you paid 2x plus 4, and the 4 is coming in because of the person who was walking, so he had to eat, he had to travel and do all those things, so that was a 4 rupee cost. And then you had another cost which was 3x plus 5, and the 5 rupee cost was because the person was the total cost was 5 rupees. So you can see that the total cost would now be equal to 5x plus 9, where 9 is the cost of the person, right? So now you can just see that like terms add, meaning add the whole numbers, add the x's, and you'll get the right answer. Now similarly, you can see that if I want to, for example, figure out what is 4x minus 5x, so let's say I'm just figuring out, so let's say so the apples were grown on my own tree, so I'm not going to include any cost. So this is the sale price per apple. So this is the sale price, okay, per apple. So I sold the apples for 4 rupees per apple, but I paid taxes of 5 rupees per apple. So clearly that means I lost 1 rupee per apple. So I'm going to lose 1 rupee per apple, and that's just the result of saying 4 minus 5 is equal to minus 1. So that was a loss of 1 rupee per apple, and that's reflecting in the minus x. So again, you can see the usual rules that we used for positive and negative numbers seem to work very well in algebra also. So if you really think about all of this, this is really, in some sense, the distributive law in action, and it's not very hard to see that the distributive law is true. So if you were to think about it, let's take this example. So let's take this example of maybe 4x minus 5x. Well, this is really 4 multiplied by x minus 5 multiplied by x, So this is just equal to, if the distributive law is true, this is just 4 minus 5 multiplied by x, which is minus 1 multiplied by x, which is equal to minus x. Now, it's not hard to come up with stories to convince yourself that the distributive law is true for all kinds of numbers. So here, remember, x can be anything on the number line. It could be a whole number, so it could be a positive whole number. It could be a negative whole number. It could be a fraction anywhere, either a positive fraction or a negative fraction. It could be anything, and the distributive law still holds. Now you may have to think about it. Why does the distributive law hold for any kind of number? But hopefully this should convince you that these kinds of things work. So for example, if you want to calculate a different problem, like maybe think about if you want to calculate what is minus 6y minus 2y, then you should be able to see that this is really equal to minus 6y plus 2y, which is equal to minus 4y. And this is really using the fact that minus 6 minus minus 2 is equal to minus 6 plus 2, which is equal to 4. So that's minus 6, which is equal to minus 4. So that's what we used over here. So let's continue our analogy of apples. So we were transferring X apples across from countries A to B to C, and the taxes were 2 rupees for country A to B and 3 for B to C. Now let's say we're also transporting oranges, and oranges are the taxes are higher, so we are transporting Y oranges from A to B and B to C, but the taxes from A to B are 4 rupees and the taxes from B to C are 5 rupees. So then you can see that the total tax cost is really equal to, it's going to be equal to 2x plus 4y, that's for country A, and then you're going to have a cost of 3x plus 5y. So you can see that the total cost for the apples is going to be 2x plus 3x, which is going to be equal to 5x, and the total cost of the oranges is going to be 4y plus 5y, which is going to be equal to 9y. And let's say as you went from country A to B, there was also a very strange tax, and the strange tax was a product tax, meaning that they would consider the product of the apples and oranges and tax you rupees 1 on the product of apples and oranges. So then you would have to pay a tax of, let's say here, you'd have to pay, as you crossed across, you'd have to pay a tax